One of the benefits of working with application problems is that oftentimes they're visual. We can draw a picture to represent what they're trying to represent. For instance, in this case, we have the top half of an ellipse as the window, so we can draw the window's base like so, and the ellipse that. Now we know some dimensions of this figure. We know that the base here is 90 inches, and we know the height is 30 inches. Given these dimensions, the window is 30 inches at its tallest point and 90 inches wide at the bottom. They're asking us to determine the height of the window at a point 20 inches from the center of the base. So if we call this the center of the base, which it may as well be the origin for the purposes of forming an equation for this ellipse, if we say that this point is the center of the base, then 20 inches from that would be like so. Note that my graph is not to scale. Alright, so what we're looking for is that value right there, the y value in particular. Now, we can, it might be helpful to first look at the general form for the equation of an ellipse. That is, we want x minus h squared over, in this case, since we're going horizontally, because the horizontal axis is larger, we'll get into that in a minute, a over a squared plus y minus k squared over b squared equals 1. So what I mean by the this parabola, or this ellipse is going horizontally, what I mean by that is that the horizontal axis is longer. It is the major axis. So notice that the distance from the origin to an endpoint of the axis, like so, is 45, half of the 90, which is longer than the other axis, which is from the origin to the endpoint of the axis, which is 30. And those values are actually just a and b respectively. So along the x direction, it goes 45, so we can say x minus h squared over 45 squared. Additionally, we know the center is at 0, 0, because we've said the center of the base is at 0, 0, so we can let h and k both equal 0. So let's make this just regular x squared, and this would be just a regular y squared, and that's over 30 squared. Recall that a and b are the distance from the center to the endpoint of that axis. All right, now we want to know what is the height of the window at 20 inches from the center of the base? Well, 20 inches from the center, notice that's just 20 inches to the right. So in other words, x equals 20. And what we're trying to find is the corresponding y value. Notice that we'll actually get two y values because the equation of the ellipse continues down this way. But lucky for us, that's just a difference between positive and negative values. When we take our square root over y in the process of solving, which we'll see in a minute, we'll just take the positive number. So first of all, let's substitute 20 in for our x. So we have 20 squared over 45 squared plus y squared over 30 squared equals 1. 20 squared equals 400. 45 squared equals 2025. And 30 squared equals 900. We can then subtract the 400 2025ths and get y squared over 900 equals 1 minus 400 225ths, or excuse me, 2025ths. And then when we perform that subtraction, in our fraction there, we'll have 2025 minus 400, which is 1625. So we have 1625 2025ths. This side is still y over 900. We can then, or excuse me, y squared. We can then multiply by 900 and get y is equal to some large number. 1625 times 900 will be 1,462,500. Write down the whole number here, 1,462,500. 462,500 divided by 20/25. And if we wanted to even, we could simplify that fraction. This is y squared, recall. However, we are just going to square root it, so I'm not going to simplify it. Instead, what I'm going to do is square root. If I take the square root of this number right here, I end up with a number like a positive or negative 26.87. Now here's where you remember, we don't care about the negative version because we just care about the y value that's positive. So we say our measurement is 26.87 and measured in inches because our original measurements were measured in inches.